Hello everyone, um, I'm Sajal Devnath, and today I'm going to cover a topic which is very much in demand nowadays. I got this request for auto scaling in VRA, V-Relays Automation, from a couple of my customers, and I see the demand growing. So I thought of writing a blog about it. So today I'm going to cover auto scaling in private cloud, that is utilizing vRealize automation orchestrator, operations manager, and NSX. So how you can actually go ahead and based on certain parameters you can auto scale a workload, auto scale out or scale in, and a workload. I would not only cover the process, but I will explain certain concepts while doing so that you would be able to not only utilize those workloads or workflows of the process, but you would be able to customize those workflows or the process according to your requirement, because every as you know that every environment changes, so you need to customize those. So instead of giving just step by step, I would be explaining the concept behind those decisions, those policies, right? So let's get ahead and start it. The first thing is, what is auto scaling? So if you go for the definition, Wikipedia definition, like auto scaling is a method in cloud computing typically, whereby the amount of computational resources in a server farm, typically measured in terms of the number of active servers, scales automatically based on the load of the farm. That means, see, if I have a cluster, say two node cluster, based on the load or say certain parameters, load on CPU, load on memory, it may be network or HTTP requests, say it's a load balancer. Based on that, the number of nodes in the cluster will increase and decrease automatically based on the parameters that I set, right? That's what auto scaling is, right? Now, there are many types of auto scaling that is possible. The first thing is, if I go ahead and try to figure out how many types of auto scaling is there, so it can be vertical scaling and horizontal scaling. So vertical scaling, that is scaling up or scaling down. Say a single virtual machine, the number of machine servers remains same. So if I have a single server, say I want to scale up, that means it had say 2 CPU, I'm scaling up to 4 CPU, and it had say 8 GB of RAM, I'm scaling up to 16 GB of RAM because it requires more resources. Similarly, I can scale down as well. That the moment the load goes, say I'm monitoring for a certain time, and then I see that it does not require that much of workload, so I can simply scale down. That's what vertical scaling. So I'm not horizontal scaling, I'm just vertically on the same node, I'm increasing the resources. And then horizontal scaling, where I scale out, either scale out or scale in. Scale out, that means it had two nodes, as I say, for example, the cluster will have now three nodes, four nodes. Depending on the load, the number of nodes increase. And scale in is the opposite of that, that if the load decreases or certain other parameters are maintained, then the number of nodes will decrease, from 4 to 3 to 1, or to 2 to 1, right? That's what auto scaling. So it can scale up, down, and scale out or scale in. For this particular example, we will cover scale out and scaling, because scale up and scale down is pretty easy. You just need to reconfigure the virtual machine. But scale out and scale in is something which is complex, so we are going to focus on that. So let's see a typical setup, VMware setup, cloud setup that you have. So you have users, they typically come to your catalog, that is VRA catalog, and request for an item. It goes to VRA request. If you have VRO in place, is a complex workloads. So VRA directly send the request to vSphere if it's a simple virtual machine, and vSphere. So vCenter server, if it has an NSX integrated with it, so it will send utilize NSX for the networking components or the other components. vCenter server will handle that, or you can VRA can directly talk to NSX server. And if I have complex say catalog item, as a custom catalog items, I will VRA will forward the request to VRO, vRealize orchestrator, and then orchestrator will work both with NSX and vCenter server to get the workloads, and then the VRA server gives you the virtual machine. That's and the end users uses the virtual machine. That's a typical normal setup. That's the end-to-end setup that you have in place for a private cloud. Now, in an auto scale setup, what we do, we have the same user. They set certain parameters, say CPU, memory, network load, or other parameters. You can set what parameters you can set. We will cover that later. But there are a lot of parameters on which I can auto scale out, auto scale do a auto scale setup. So they will set those parameters, and then VRA, they will interact with end users, will directly interact with the VRA. VRA in turn talks to vCenter server, which in turn talks to NSX or VRO. So those are all integrated, and then again VRA, ultimately VRA fires up those scale up or scale down for a particular virtual machine, that kind of setup. One added environment that we will added component that we will add is vRealize Operations Manager. It is not a mandatory setup. We can work with vCenter server as well, but with only vCenter server, the number of choices that you will have will be limited. So it's better to use vRealize Operations Manager, so that the entire process will entire parameters for your scaling up and setting your auto scale will increase, right? So your vRealize Operations Manager will monitor vCenter server and NSX, and it will fire the notifications to VRO, which in turn will work with vRealize Automation Server, and then your workload, say you are scaling up, that will work. That's what a typical auto scale setup is, right? You can just scale up or scale down, so increase the node or decrease or remove a node. It all depends on this particular setup. Now, if we go back to this, I said notifications, because your environment need to know when to scale out or scale in or scale up, scale down. So you need to have a notification in place. Now there are multiple types of notifications that you can use. Uh, Typically SNMP traps and REST API, right? So when you choose SNMP traps, we can use both vCenter server and VROPS. So as you know that vCenter server monitors your virtual environment, so it can monitor and raise alerts and send notifications through SNMP traps. So when I am utilizing only SNMP traps, I can utilize both vCenter server or vRealize Operations Manager server. But when I'm talking about REST API, only I will have to utilize vRealize Operations Manager along with webhook shims, because the setup that we are going to do. So VROP server only provides you the REST notifications based on REST API, and since VROP server has its own proprietary process of REST APIs, which is not directly understandable by vRealize orchestrator, we need to have webhook shims which will convert that. So we will just depict that. How the traps work. Say you have a vSphere environment, vCenter server on which a virtual machine is running, and it raises an alert, say CPU alert or some other alert. So vCenter server simply sends one SNMP trap to vRealize orchestrator. vRealize orchestrator in turn processes that and then submits a job to vRealize automation through API. vRealize automation in turns creates the VM in the endpoint. It may be vCenter server or anything else, which gives you the virtual machine. Say another virtual machine. I'm just scaling out here, and you can use vRealize Operations Manager as well for the alerting mechanism and SNMP traps and the entire notification process. vRealize Operations Manager gives you a lot of other options. We will just see that, right? And now when you come to webhook shims, the REST API notifications, we have a vCenter server. The VM is running there. So a VRealize Operations Manager monitors that environment, and for any alerts, it sends the REST API notifications. Now I need to process that, so I need webhook shims in between. So it will process that VROP's proprietary payload and then convert it into into a format which VRO, Various Orchestrator, understands. So webhook shims will process that and sends the trigger to VRO. VRO, Various Orchestrator, will handle that request and then submit a job accordingly, say scale out or scale in to vRelease automation server using the APIs that it has. vRelease automation in turn will ask the endpoint to create the virtual machine or delete the virtual machine according to the kind of alert that it generated, and the machine would be created. So a virtual machine would be created into vCenter server or any other endpoint that you have. So that's the entire workflow of using the notification, right? Now, if we think about the steps that we need to do, first we need to configure vRelease Operations Manager. There we'll have to configure the outbound settings, SNMP or REST notification. Then configure symptoms in VROPS, that which symptoms we want to monitor. Configure the alerts, then configure notification for the outbound setting. That's what we need to configure in vRelease Operations Manager. In vRelease Orchestrator, you need to import the package that I'll be sharing at the end of the session. That package has all the workflows in it. So you need to import the package and then configure the workflows as per your environment. It needs to be given certain parameters which depicts your environment, and then you will have to configure the trap receiving mechanism. If you are using SNMP trap, so you will have to give the environment so that it can process that SNMP trap. So in VRO side, what you need to do, configure SNMP trap host. If you are using SNMP, so you will have to configure the trap host. You need to configure the policy, and in the script you need to modify the script as per your requirement, as per your environment. And if you are using REST APIs, then you will have to configure webhook shims and then configure workflow to handle the REST notification. That's an overview of the steps that you need to do. So all I am doing, it's pretty simple, that you get an alert, you send a notification, you handle that notification in VRO, and send out a job to various automation server. That's the entire workflow, right? So before I go ahead and showcase exactly how you need to do it, just an overview of my setup, right? So I am utilizing a multi-tier application, multi-tier blueprint. I would be utilizing. It has two tiers. You can use multiple tiers, three tier or whatever is suitable to you. Uh, so I would be using a simple web tier and a database tier. So DB server will have SQL server, and everything is Linux based in my environment. You can utilize Linux, Windows mix of that, or pure Windows environment as well. So it's just two-tier application. I have a web tier and a backend database server. In my use case, I'm using a single node database server. My web tier would be scalable. It would scale out, scale in. So the the IPs, my web tier is running on 172.16.10.x range. My DB tier is running 172.16.30. Oh, it should be 30.10 range. Let me just correct it. Otherwise, it will create a lot of confusion later on. So it's 30.90. That's my web tier. And so my web tier is connected to an on-demand logical load balancer. When you deploy that blueprint from the catalog item, it will deploy an on-demand load balancer. The beauty of NSX with VRA is you don't need to configure the load balancer at runtime. Pre-configure that, or post configuration, post deployment, you don't need to touch it. So when you scale out, a new node will be automatically added to the load balancer, everything configured for you. It should start working as it is. And if you do a scale in, that is, you remove a node, the node will also be removed from load balancer. You don't need to configure anything. How cool is that? Just imagine in your production environment you have say a 10 node web server in front, and you started with one node. As and when the load comes, it increase the load increases, the nodes also increase, and the load balancer is automatically configured for you. You don't need to do anything. If the load decreases, the nodes decreases, and the load balancer is automatically configured for you. That's the beauty of NSX plus VRA. So the load balancer that we have has an IP of 172.16.10.90. That's a fixed IP that I have chosen for this environment. You can have a dynamic IP as well. That is connected to this setup. Left hand side web is connected to web logical switch, and my DB server is connected to DB logical switch, and both of these switches are connected to a distributed logical router with the name routing-DLR. The gateways are 172.16.10.1 and 172.16.31. That router is connected to a logical transit virtual switch, which is a logical switch which is connected to my edge gateway. So the transit switch, the router which is connected to uplink for the router is 192.168.10.2, and the inside link. So for the edge gateway is 192.168.10.1. So for router, the gateway is 192.168.10.1. Now that logical route, that edge gateway that I have also works as a NAT. So I have NAT configured in there. So the an external network, net for edge is 10.115.48.85, which is connected to my logical physical router, which is gateway is in 253 range, and this NATing converts my logical load balancer IP 172.16.10.90 to 10.115.40.71, so that I can access the load balancer. I can access the web server from outside. So I can only access the web server from outside. I cannot access the DB server from outside. DB server and web server can talk to each other, but from outside, DB server is not directly accessible. Right? Cool. So that's my entire setup. Multi-tier node is set up in this way. Right? Before I go ahead, webhook shims, what it is. Steve Flanders written a beautiful blog. Go ahead and check that blog. John Dias, amazing set of blog posts, 5-part series. He has given screenshots and step-by-step kind of ways to configure webhook shims, how you can go ahead and configure it. So definitely go ahead and check that if you want to configure webhook shims, and the last link is where you can get it. Right, I'll just showcase all these websites or the blogs in a minute, but before I wanted to do that, I wanted to say thank you to Kirsten for the main workflow, the scale out and scale in workflow. The scale out workflow was shared by him. I modified it to tweak it for the scale in. It's a very small minor tweak, and then certain portion I had to modify. But the thing is, the main workflow, absolutely amazing work by Kirsten, and then Vishal Jain, Diwan, and the team for load balancer handling. Because when you get a notification for a load balancer, you get the load balancer name. But from load balancer, you need to come to the virtual machine name. That conversion was done by Vishal Jain, Diwan, and the team. Amazing work, guys. And Vinith Menon for that one-liner. You do a lot of web testing. I was wondering how can I go ahead and put load on my web server. He has given me that single one-liner PowerShell commandlet with invoke REST command, which puts the load and made my life easier. Thank you, guys. And above all, at the end, guys, go ahead and check http://feedtechguru.com. That's the blog where I will write details about this process and stuff. So you go ahead and check the blogs. That's where I regularly blog. Right? So let's start the demo, and let's see the web pages that I said. So Steve Flanders, he explains what is webhooks, why you should utilize it, and where you should utilize it. Go ahead and read it. Very good blog. And then amazing blog by John Dias. Step-by-step configuration, detailed step-by-step configuration, how you would go ahead and configure webhook shims in your environment. These are the blog series. and at the end, this is where you will get the webhook shims from VMware for VRO and VRA VROps integration, right? So this is my setup. This is my VRA server. This is my vCenter server. VRA's operations manager, and this is my web server. So it's I have 10.115.48.71. This is web 01. This is a test website that I'm running. So this is my web 01 and DB01 database server and web server, and this is my on-demand load balancer, edge multi-tier auto scaling. Let's go ahead and check the networking portion, the logical switches. You can see that apps, DB logical switch, web logical switch, and transit switch. I have logical router, which is the distributed router that I have shown, NSX Edge, where I have configured the NAT portion, and this is my on-demand load balancer. This gets deployed when workload in VRA is deployed. So if you look into the load balancer, that is enabled. Application profile, you can see that there's an application profile. I'm just only working on HTTP server monitoring using the default monitoring specifications. Pools, I have a single pool on demand round robin method, and you can see there's only one member, that is 172.16.13 sorry, 172.16.10.3. That's my web server. And then the virtual servers, you can check. That's in my pool in I have only one single server, right? This is my virtual server on demand IP, that is 172.16.10.90. That's my virtual IP for load balancer, right? That's my current setup. So if you look into the IP of the edge, that is my on-demand load balancer IP, and then web is 01 is 10.3, and after natting, that is 10.115.48.71. So these are the setups that you can configure pretty easily. Netting, I will just showcase my NAT configuration. So this is my main edge gateway, and this is my source NAT and DNAT destination NAT rules. So I am just 172.16.30.90 to translate it to, oh sorry, this 172.16.10.0, any load balancer would be coming to 71, and then anything that comes into that would be, instead of 71, would be converted to 90. That's my load on-demand load balancer. That's my setup. You can modify and change it according to your environment, your requirement, right? And just to showcase, these are the workflows that I have. So these are the work. If you import the package, these are the workflows that you will get, that entire 8 workflows. So what I have done, I have written workflows to handle SNMP traps and webhook shims both. So you can utilize as per your requirement. 4 workflows I have written, 2 for CPU and 1 for 2 for load balancer. CPU scale up for CPU load, scale down for CPU load, scale up for load balancer load, scale down for load balancer load. So I will cover those in detail later on, but I will showcase my blueprint first a bit, so that you understand how it's working. So this is my vRealize automation server, and if I go to design blueprint, one thing is there, I'm deploying the web servers, just base machine, and I am deploying Apache on demand. So when the virtual machine gets deployed, Apache web server gets deployed as well. So I have those scripts ready, that I install HTTPD and then configure the default pages and stuff, and then I start the web server. So it will be on demand. So it's actually to showcase the software component as well. So this is my blueprint which I'm utilizing for this demo. It's a two-tier deployment, right? So I have a web layer and DB layer. Web layer is utilizing a particular reservation policy, and it can scale up to 6 instances, because obviously when you go ahead and configure auto scale, you need to put an upper limit, otherwise it will go ahead and consume all your resources. So I'm using a base template and then specification, right? For network, I'm just utilizing a load balancer. I will be utilizing, and then it's connected to web net. And for security profile, I'm utilizing activity monitoring. By default, the machine would be added to the activity monitoring security group. Similarly, for DB layer, I am utilizing the reservation policy and then build information. The on-demand load balancer has a fixed IP. You can use your dynamic IP as well, and the virtual servers will be configured as HTTP. You can configure other rules as well. So you can simply add new rules here. Say it may be HTTP, HTTPS, TCP, or something else, right? So that's my blueprint, right? And you notice this Apache web server. Uh, so typically it's I'm not no, at the runtime I'm not passing any properties. It will just go ahead and configure itself, but the Apache web server will be deployed first. And another point to note, when this blueprint will be deployed, DB server will always be deployed first, because the note the interdependencies. So DB server will be deployed first, and then the web layer will be deployed, because you want DB server to be up and running first. So I'll be utilizing this catalog for so I have utilized this catalog item to make a request, and I have an item here. Now one point to note, this scale out and scale in is always configurable at the deployment level, because you do not want each and every component to be scaling out and scaling in. So it's always deployed at the scale out and scale in level. And just to showcase, when you configure this blueprint and then you go ahead and in the catalogs management, you go ahead and check in the entitlements. You need to have scale out and scale in as an action. You need to do that. So for example, I have this entitlement, and here I have chosen scale out and scale in the deployment level. If I do not give scale out and scale in as an option, then it will not uh, come in the here. If you select the deployment, I can see the components in the deployment section. If you click on deployment and then actions, you see that scale out, scale in. So by default, out of the box, VRE provides you these two options of manually selecting scaling out or scaling in, and that is always applicable at the deployment level. So if you do not give the entitlements there, it will not come here and you cannot utilize it. Now our task is to automate this scale out and scaling. So we will fire an workflow or say trigger from VRealize orchestrator, which will start this scale out and scale in automatically, right? So that's my setup at the VRA level. Now let's set the notifications. So the first thing that you need to do, I did another blog on that, but here I will just cover it again. So go to administration. First thing is set outbound setting. If you are utilizing SNMP trap or SNMP notification, so first you need to set a server. So I have selected the outbound plugin as SNMP trap, give it a name. Destination host is my VRO, VRealize orchestrator server. Port item I am utilizing port 4000. It always works, and give the community name. So you can simply go ahead and add, select the plugin type. I have selected SNMP trap plugin, give it a name, and then the VRO server name, and then port number, say 162 or 4000, and give it the community name. And that's it from your outbound setting. We will see how we can configure it in the VRA side. later on, but this is how we will configure it here. Similarly, for webhook shims, we will cover the webhook shims later on. Let's first cover this SNMP first, and then we will cover the webhook shims portion. Uh, so webhook shims and SNMP, the only difference is the outbound settings you will have to configure it here. Rest of the configuration remains same for each one of them. Then go to content. First, I will set the symptom definition. I need to define the symptoms. Symptoms may be of four types: metric, property, event symptoms, fault system definitions, and metric event systems. I have a detailed blog on that, how you cover this entire notification stuff. So you go to http vtechguru.com and you get that blog, which actually showcase. I will show it here once. vtechguru.com, which particular blog post shows you the notifications. So go to vRealize operations. See this, learn all about VROPS, REST notifications and REST APIs. So that is what you need to go ahead and check about REST notification. It talks in detail about alerting and notification mechanism, how you can do it. I will just showcase it here once again. So I have this notifications, these symptoms defined here. So I have four parameters that I have defined. I wanted to go for VM CPU usage down or high, and then load balancer low or high. So see, if you CPU usage high, what I'm doing, I'm selecting a base object type and I'm monitoring all the virtual machines. The base object type is virtual machine. So you select the type and you get to see all the parameters. Now this is the reason I would use vRealize operations manager over vCenter server, because you have all these parameters available to you. You can select any one of them as your monitoring parameters. You do not have these many options in vCenter server. You simply do not have. So what I did, I selected CPU and then utilization usage. Simply click and drag it here and it would come here. So this is CPU usage. If you want to monitor according to memory, you can simply go to memory and then you can select the memory usage percentage as here as well. I gave it a name, is critical when the metric is greater than 80%. So I'm saying if for any virtual machine, if the VM CPU usage is greater than 80%, send me a critical, it's a critical situation, and the wait cycle is 1, cancel cycle is also 1. Similarly for load balancer, just notice, I will just showcase it here. I have selected NSX. Okay, for this load balancer to work, you need to have NSX plugin to be enabled in vRealize operations manager. So I have selected the type as NSX adapter, and then inside that adapter I have selected the load balancer service that I have, and in that if I go to virtual servers, I can get HTTP request rate. So look at the parameters that it gives, the details that you can get from your load balancer. So that is the beauty of using NSX with VRA and VROPS. The kind of things that you can monitor, you can see the number of sessions and then pools and everything. So you can select all those parameters. So I'm just selecting load, giving it a name. So load balancer load is high, and I'm monitoring virtual server HTTP request rate. Even is greater than or equal to 15, then I send me an alert. I know 15 is pretty low, but for my testing environment, that's what works. So works in the sense I wanted to keep it pretty low. I just want to showcase how it works. Similarly, for load LB load down and then CPU usage, I've created this system definitions. Next, we need to define alerts for those. So again, so for each one of them, like CPU usage high, I have created an alert, given it a name, and then base object type is again my virtual machine. So any virtual machine should come into that. Alert impact is health impacting. and the criticality is symptom based. That means if symptom says that it's critical, then it's critical. Okay, and alert type and subtype, it's my virtual machine, right? So virtual machine and performance is the category. If you select into that category, availability, capacity, compliance, configuration, here it's performance related issue. And then wait cycle is one, cancel cycle is one. Then add symptom definition. I have it's on metric or property based, symptoms that you define. So I have selected that, and then the symptom is CPU usage high or down. So I have selected CPU usage high. Just click and drag, and then I don't need any recommendations. I'm just defining the alert. So my alert is defined. Now what I need to do is notification. So I have created 4 notifications. So CPU usage high, say let's take this. Now I gave it a name. You need to select the method. I am selecting SNMP trap plugin, and select the outbound setting. You remember outbound setting we did orchestrator SNMP notification. So we are selecting that, and then scope is virtual machine, object type virtual machine, any virtual machine we want to see that. Alert definition, select you can see, just drop down and then you can select it on based on object type or object or tags, application tiers. You can see it all this thing. I will select it on object type because I wanted to set an alert on any virtual machine that has this particular alert. It should send me a notification. So I have just selected vCenter server adapter and then virtual machine. Notification trigger, simply just go ahead and select the notification trigger from here, search for it and then get it. Criticality is critical. Advanced filter, I am selecting that alert state is open and new because I do not want to be alerted for each and everything. You can change it according to your requirement, just assign suspended or alert state is cancelled or updated. And then collectors, if you have multiple collectors, you can select the collector or you can choose the default one, right? So this is my SNMP trap plugin that I have configured here, right? So CPU usage high is using the outbound instance of orchestrator SNMP notification. I have configured everything from VROPS perspective. Next, we will have to go back to VRA server. So now we want to configure SNMP, right? So the first thing that you should do is go to library under SNMP device management. You need to register the SNMP device. So if I just showcase what I did. So you are registering your VROP server. I am registering my VROP server, and then I am saying the port number and the community name. You remember those same configuration we gave, and then submit. So now you will have one SNMP server configured in your environment. The SNMP trap, SNMP host or say server host that you have configured in your environment. Okay, now I can see in the SNMP traps that the host is online and I have these 2 hosts. Next, what you need to do, you need to go to administer portion. It has 3: run, design and administer. You go to administer mode, administering the VRO mode, and you go to this policy. This is your policy tab. The second tab is policy, and then you create one apply policy. If you click on apply policy, that SNMP trap, just give it a name and then select the device because you need to keep monitoring that particular device, right? So we will just go ahead and select the say VROP server as selected and then submit the trap. When you submit the trap, it will come, just submit the policy, come to the run stage again and then go to the trap. You would see that this trap will come here. So I have defined 2 traps here, and in this trap now you would receive the SNMP traps, but you will receive all the traps. You need to process that information so that it would send you required information. So on trap, if you come select the policy on the right hand side, you'd select that, you'd get to see that this trap policy is running under that the device. And then on trap, what to do on trap, you can directly run a single workflow, that whatever trap runs you can set the workflow. But the problem is, in our case, and the other problem with SNMP trap is each and every SNMP traps is going to come. So you need to process for, look for particular notifications and run workflows accordingly. So what I'm doing, I'm getting the system trap, writing it out, handling the trap here, and then I have mentioned the workflows, the 4 workflows that I want to run for SNMP traps, the workflows that I want to run. So I need to get the UIDs. I will just show where you get the UIDs of that. Probably I can show it here. Okay, so for any say this is my SNMP trap, this is my workflow which I want to run based on the load balancer. So this is your ID. So you need that ID here. I'm just storing that I need to run this particular workflow, and we would need this for later REST API as well, webhooks. And then now you can process the SNMP traps in many ways. There is no single way. I will just showcase you future past runs. The way you get the traps, the information that I get is in this particular format. You see the elements, you get the elements, and the elements are numbered always. So it starts with 1. So element 1, 2, 3, 4, 5, and then goes 21. And you see each and every element is an object. It has an OID field which is unique for all of them. You notice the OID is unique for all of them. So either you can search for the particular OID, and this element, the SNMP trap gives you an array of objects. Each and one of them is an object. So you can process each and one of them individually and see the value type. It gives you the time takes, each and every value it tells you. And for me, the important thing is, the interesting thing is this element 4 with OID this. So you can check so many traps, whatever traps it has, number 4 will always have the same OID and the value, right? And then number 11, the element ID 11 gives you the trap information. It gives you the object name as well, on which object it has done, what is the metric, and all that information. It goes till 21. 21 is your, so number 1 to 21 is your elements. So there are ways you can simply receive the trap and then go through, loop through the trap to look for particular OID, because you know that OID of element 4 gives you that particular information. Here I am not looping through it, I am just checking, because I know result 90, that 19 element number 19 gives me that alert name, the alert that fired this SNMP trap. Element number 19 gives me the name, and element number 4 uh, actually gives result 3, which is element number 4 gives me the virtual machine name, or the entity or the object name which fired the thing. So I only want 2 things, that what was the alert that was fired, the alert name and the object name. So if the alert name was equal to this, then I am saying that trap is found, and just storing the value into VM name parameter, that I got my thing. And then I'm saying workflow ID is workflow CPU high. That means I need to run this particular workflow. So I have a workflow which is for scale up, say scale up blueprint layer based on VM MOID. So I need to run that particular workflow. So this is my workflow ID. So I'm just copying that CPU high. So whenever I am receiving a trap which says VM CPU usage high, this particular alert name, I'm storing the VM name, and I'm setting the workflow ID is this. Similarly, VM CPU usage down. Now, since I wanted to do a load balancer for a particular load balancer, one interesting thing happens. If it's coming from a virtual machine, I get the virtual machine name. But for load balancer, the name is, I get the load balancer name and appended by the the words load balancer. This is extra word. So for a load balancer, handling a load balancer, I need to strip it off the load balancer portion. So I'm just stripping it off the load balancer portion and getting the load balancer name. That is what I am doing. So I got my workflow IDs and everything set. Now what I'm doing, I am saying finding the modif, because my vCenter server understands modif, right? Managed object reference. So you have the virtual machine name, and vCenter server has a modif name. So like VM-141, 171, or something like that. So I'm just getting that modif through this find VMs function, and then I'm just running this workflow, passing this parameter to run this workflow. That is what I'm doing. So that is how I am handling the SNMP trap. So you need to do that as well. Coming back to the workflows that we have. First of all, before you go ahead and do this, you need to add your NSX server here. So that is obviously you will have to configure NSX server when you want to configure NSX in your environment. So I will have to configure NSX server here, and then vRelays automation. Go to vRelays automation configuration, add a VRA host, and then add the IaaS host. So you need to add these two hosts. So the way VRA host is known in VRO is VCAC cafe host, and then IaaS host is VCAC host. So you need to add these two hosts, and okay, so HTTP portion we will cover, REST API we will cover later on. For the workflows, you need to say scale up blueprint layer based on VM MOID. If you go ahead and select that, you need to set the parameters. I will just show it here. So scale up, you need to do it for both scale up and scale down. You need to select, if you see cafe host, you need to select it here. If you go there and it will show you the cafe host, just select the host. For VCAC host, you need to select it as well. There is your IaaS server that you have added. So you just add the IaaS server, and then this operation scale out action, you need to select the host and then go to items. Under the items, you need to select the particular deployment. So for my environment, this is my deployment. On that deployment, go to actions and select scale out. So this is configurable per deployment basis, because you do not want to enable it. You can automate that as well, so you will have to write separate workflows for that. I just wanted to showcase the basic workflows. So just select scale out. So similarly for scaling in, you will have to select all the parameters, but instead of say scale down a VM blueprint layer based on VM MOID, in this you will have to select the scale in. Instead of selecting scale out, you will just select scale in. These is the two things that you will need to do. And for load balancer load SNMP based, you need to again select the host and then NSX host. This NSX connection, you need to select this NSX host, the NSX host that you have added in the earlier case. Similar things for scale up based on load balancer SNMP trap, right? So that is the setup that you will have to configure for SNMP, configuration of SNMP. What we are doing in say scale up blueprint layer based on VM MOID, this is typically the inputs are there. Inputs, as an input, I'm just processing that modif. So as an input, I'm getting the modif, and then getting find object by ID. This is an action. This is also part of the package. then get entity from VC. This workflow entire a workflow is written by Kirsten. Amazing work. Again, I need to say. So it fires submit to VRA workflow. It uses the submit to VRA and count VMs in the layer. This SNMP traps workflow, it depends on these two particular workflows, and then it does the work. So let's go ahead and check it. After you configure everything, start the policy. You'll have to start the policy and go for the logs, right? Let's go back and put some load. So we have web 01. We will put CPU load there. Yes, dev null will increase your CPU utilization to 90%, 99%. We will have to wait, say web hyphen 01. Go to alerts. So the VM CPU usage down, since it's my lab environment, it pretty much has uh, what do you say, very less utilization. The utilization is always less than 10%. CPU usage down workflow, that notification is always fired up. So I have configured, tweaked it in a bit so that it will not send a notification trap. So we will keep monitoring the environment for VM CPU high workflow, and for our reference, it has only web 01, and the web server that has the load balancer, it's only one single load balancer that we have. This is web 01. So we will have to wait for 1 minute or so that this notification will be fired, because the monitoring time frame for VROPS is minimum 1 minute and maximum five. Maximum it can go up, but uh, generally it's 5 minutes. That's a collection period. For my web use case, I have lowered the monitoring time, monitoring gap frequency to 1 minute. So the CPU utilization is going up. We will probably wait for 30 more seconds for that notification to fire here, and in here let's let's wait for it. And at the time, so note these workflows. You have scale down for VM, blueprint layer based on VM MOID. That's your based on CPU usage or memory usage. You can use that. This is an SNMP trap based workflow that you have. I have configured, and then you have scale up blueprint layer based on MOID, and then you have both of these for load balancer, scale down and scale up, and the rest of the four workflows are for REST API based notifications. Till the time it gives me this notification, you can actually go ahead and see how we can reduce the frequency of monitoring. So go to home and say environment, all objects, and from the left hand side say select vCenter adapter, and then say select vCenter server. Just a second. We will come to that later on. By this time our alert should have. Okay, so we have this VM CPU usage high. That trap has been that alert has been fired, and you can see that the trap here. I can see in the log that the trap has been fired, and it gives me the details and says calling out to workflow run function. If we go to workflow, you'd see that scale up blueprint layer. This workflow has fired and it's waiting for a task. It gives you the detail trigger created. You see the creating trigger for resource action request, and resource action request with the id that has been sent. The trigger is created. You go back and see where is automation. You go to requests. You'd be able to see that there's a scale out action that is there, and it's so you'd be able to see that there's two parallel tasks. So actually I have fired two tasks in in parallel. So one, this particular scale out operation is in progress. So I cancelled by mistake. I cancelled one, so two say subsequent alerts was were sent. So this task is going on. So if you go to see the things, that on limit load balancer is waiting, and then VM deployment is in progress. You see that the clone virtual machine, that web 02, that is being deployed. So that particular virtual machine is being deployed. So it actually fired a scale out action, and it's creating another virtual machine. So the tasks that we will do, it will deploy the virtual machine, and then it will deploy Apache web server, and then update the on-demand load balancer. So till the time it does so, let's go ahead and configure the REST API portion. Let's cover that REST API portion. So you understood the SNMP traps. The way I'm handling it is simply firing the the trigger, and the trigger will fire a workflow in VRO, and that VRO will fire the workflow, which will in turn trigger a task in vRelease automation server. Right. So let's this go. In the meantime, let's go ahead and configure the other tasks. Let's remove this. Okay. So now I will show how you can actually go ahead and configure webhook shims. Now go to administration and outbound settings. Right. Before I do that, you will have to have to configure webhook shims in your environment. So the steps is given by John Dias. Detailed steps. So I have my webhook shim server ready and running. So this is my webhook shim server which is running. I can see the outputs here. The way you would configure, say I change this for webhook shims. See, the way I would configure is select the REST API plugin, the plugin or REST plugin. Let's start add one. So the plugin type is you select REST notification plugin and then give it an instance name. Then give you the URL. So for my case, my URL is this HTTP URL, and then note the endpoint /endpoint/VRO, and after that the workflow ID that you need to run. So note that very clearly. Like for example, I have shim scale up based on CPU, scale down based on CPU, scale up based on load balancer, scale down load based on load balancer. So for example, for the next use case, I want to scale up using the load balancer load. Okay, so here the workflow that I have corresponding to that is say scale up based on the load balancer load, scale up via a deployment based on load balancer load. So I will just copy this ID and scale up load balancer load. After this URI, all I need to do is give this ID. So what will happen? Unlike SNMP, where I had to receive the all the traps and then process it, here I am doing what I am doing. Once the notification comes, it's directly going to call out to the workflow. I don't have to do a separate processing at VRO server. Simple get the notification, direct calls out the workflow. I don't need to do anything. Change the content type to application JSON and save. Now note that if you click on test, the testing will fail here, but that is okay. You don't have to worry about that. Just click on save. Give it a name, instance name, and thing. So this is my outbound plugin. So I have 4 workflows there. So I have 4 outbound plugins. Now this is your outbound settings. Go to notifications, come back, go to notifications. Now for that CPU usage high, say for example I was using SNMP traps, I will just configure it to use REST notification plugin and then select the respective REST. So this is my VM CPU usage high, so scale up based on CPU memory load. I can use the same workflow, same notifications for memory usage as well. And object type is virtual machine. Again, the rest of the configurations is same. For my test environment, what I have done for CPU usage down, say load balancer load down workflow, since my environment is pretty less, so it will always say that notification. So what I have done, instead of creating it on object type, I can create it on a particular object, and or say when I suspend that particular alert manually, then only it fires and workflow. So though the alert is fired, but it does not send a notification. Only when I suspend it, then only it will send me a notification, right? So that's how I have changed. You just configure the notifications using the outbound settings. Rest all configuration is same. Let's see whether it has still in progress, or it's still in progress. It's powering on. Okay, so this is how I will configure the webhook shims. Configure the webhook shim server in VROps side. Just change the outbound settings. You need to configure the outbound settings. So you have 4 different notifications, 4 outbound settings, and then set the notifications here accordingly. Here the workflows for the REST notifications is a bit different. So the inputs now here what you will have to do is, for webhook shims, you need to go to HTTP REST configuration, add a REST host. So add a REST host, that is my VROP server, and the URL is VROP server / suite -API. That's my entire URL for REST host. And configure the rest of the configurations, like authentication type is basic, provide the user ID password, and then whether you want to use proxy or not, and then for SSL server we want to accept it, or how the way you want to do it. So you add the REST host, and then you need to add REST operations. So the REST operations that you need to add is this 2 REST operations. One is get alert. So you select the parent host. So you have added the HTTP REST host. So you select the host and then define the operations like get alert, and the template URL is this API alerts alert ID. So this is a variable it will take at the runtime, and the method is get. So this is one method, and the second method that you will have to do is get not properties. You will have to to the resources. Okay, this one. So you need to get the details, get VM name, give it the exact name, and the template URL is API resources resource ID. One interesting thing is, you see VROPS REST API documentation, whatever REST API template URL that you see there, you can use it and utilize the REST operations and process it according to your requirement. The output is the same JSON format, and it's JavaScript, so handling JSON is pretty easy. So you just need to add these host first, and then operations, HTTP operations, and then come here and JSON invoke REST operation. First, get VM name from VROPS REST notification. Here, get alert. You need to set this get alert and resource ID. I have mentioned it here. So these two operations, you need to set the values here. The way you can do it is just edit this workflow and go ahead and select it, and select the rest notifications that you have done. Get alert, and then for the other one is get VM name is get VM name. That's the setup that you need to do before you can actually utilize and utilize these workflows. So you need to do these two. And if you look at the workflows, that's pretty much straightforward. You don't have to configure anything here. It just gets the process the thing. So if you look at the schema, so I am getting the trap, and then I'm just running that workflow, get VM name from VRE, and then get VM modif, and then scale down. I'm utilizing the same scale down or scale up workflow, but before that I'm just processing it separately. For a load balancer, I will have to bit different. I'm just getting the VM name from, so I'm getting the VM name, that is age. From age name I need to get the LB name. From the age name of the LB name I'm getting the VM name, and then from the VM modif, and then that same workflow that I'm running. Same these two. So the core workflows that I'm using is this, and this one, and this which was written by Kristen. I have built on top of that. So again, thank you. Let's see this particular virtual machine whether it has been okay. So it's successful. Let's go to items, and you see that that scale out operation, it has now web 02 as well, right? So web 01 and 02, the scale out operation. Now if you look into it, web 01 and then web 02, my web server, my load balancer is also working. I didn't do anything on the load balancer side, it just works. If you go ahead and check the load balancer actually, so we will do that. So let's first fire and workflow based on uh, webhook shims. So now everything is configured on webhook shims. We would put some load balancer load. This is the one-liner that my friend Vinith Menon provided. This single word one-liner which puts a lot of load on the load balancer, request to the load balancer. So I'm just running that PowerShell one-liner command, let invoke web request. So it's just going to throw out a lot of web requests to my web server. Now if I go back, I want to monitor my web server. I will go there, environment, NSX edge services. This is my edge, and this is my load balancer. This is my load balancer, that's the name. So actually this is my edge name, and then this, as per the service, it adds load balancer or say firewall or something. So I will just monitor the parameters that's there. So right now there are no alerts. We will monitor that, but in between let's go ahead and check my NSX load balancer configuration. We have added one component, right? So if you go to NSX edge, and this is the on-demand load balancer that was deployed at the time. If you go to load balancer, you see pools. Now you have two members, member 0 and member 2, member 1 and member 2. I didn't do anything. It, when the scale out happened, it actually added this particular member into this pool, right? And you can see that my web server is running absolutely fine. It's doing a round robin method. Let's wait for this alert. Okay, so the alert is, let's load down. So I have my workflow. I have stopped the load and it started configuring this scale out option. So I can see that this web 03 is being deployed based on the load balancer load, and right now I have only 01 and 02 as the load balancer configuration. If I go ahead and check into NSX server, as we were seeing, these are 3 and 4. It's still deploying. It's in process. The web layer deployment. So right now it's just deploying the web server 03 and then and deploying the components, the Apache server. So let's just wait for this deployment to finish. Just note one point, when you go into request you can see that my tasks was one failed, one successful, and then one is progressed and one is failed. The reason behind, and probably why you shouldn't utilize SNMP again, that I had SNMP configured and I forgot to stop the SNMP monitoring. So what's happening, that it's found the LB load high, the trap found LB load high, and it sent me a notification for that as well. So I had two parallel tasks, one from SNMP trap and one from REST API trap. So that's why one failed and one is in progress. Whichever came first, it worked, and the second task failed because you cannot have a concurrent scale out operation, right? So see, notice, though I disabled SNMP trap in notifications, but since there was another alert, that is a system generated alert for VDOPS, that was saying that same thing, that CPU high. What it did, it sent an SNMP trap and then it fired my workflow actually, right? So you should have any one of them in place. So let's see progress. It's still deploying. Let's go to the execution information. Web layer is successfully deployed, so that now it's just deploying the software components, and if you look into it, it tells you the details that it's doing. See, I'm just installing the yum, running yum, and that running the HTTP installed. I can see that HTTP is installed, and configuration portion, it has not started. For the start portion, I can see that it created the symbolic link. So my entire workflow is finished, and you see that on-demand load balancer is also configured. So let's first see the web page 1, then it should 2, and then it's 3. You remember the round robin, so I have 3 web servers now. Web server 1, web server 2, and then web server 3. 3 web servers. You go there and do a refresh. Now it should have 3 members. See, the members automatically added to it. So my work is scale out is working fine based on CPU or the load, or it's REST API, or the other way. Now what I have done, since I have removed the load, the LB load down is a parameter that I have said that it's there. It's already there's no load. So the moment I suspend it, it should send me a trigger. So let me just suspend this this notification. See, I want to now scale in 60, right? If I go back here, Now see the task that's completed, scale up. Now scale down, see the scale down via a deployment based on load balancer. It fired this load balancer based on VROPS REST notification. So it started doing scale down VRA deployment, and then see the trigger. So it's doing and it's waiting for the event to finish. So it's, if I go to my VRA server and if I see my requests, there should be, yes, this scale in request is in progress. So that scale in request should remove the node from the cluster, and note what happens when, while removing it, removes the last added. So I have web server 1, web 1, 2, 3. So it should remove web 3 first and then do that one. That's the sequence in which it scales in, right? It's just doing the bird deletion. Okay, we will have to wait couple of minutes for this to finish scaling in. And note that on-demand load balancer, it is waiting for web layer 2. That means web layer 2 is in progress. Its component type is vSphere and its component ID is web layer. So this should destroy first. So this would be destroyed. Apache web server will be destroyed, and then it would be updated. On-demand load balancer would be updated. So it tells you that what exactly it's going to do. Right? So I need to destroy my machine, and then the rest of the operations will follow. So look at the operations that's being done in the vCenter server. So it powered off the machine and then deleted web 03. And if I go back to VRealize automation, I see that web layer 2 was deleted, Apache web service was deleted, Apache web service deleted, and in progress is on-demand load balancer updation. So everything is successfully run. So if I go back to my load balancer, I should be this third web layer. Let's see, the web 03 is gone. And if I go to my load balancer now, if I run it, it should be only 1 and 2. There is no 3. It's deleted. So that's how it's scaled in. You go there and you see that it was successful. So you see the kind of work that you can do with this based on it. This was just a demo to showcase how it works. And this was suspended, and then it fired the workflow. And if you go back here, I can see that scale down deployment based on load balancer VROPS REST API. This particular workflow ran successfully and it did a scaling. So as you can see, I can, based on SNMP trap or direct REST API, I would personally prefer REST API because that's much cleaner. I don't have to write that script to parse the SNMP traps, and then SNMP traps always works for each and everything. I will get a trap and then I will have to parse it. While in REST API, I just mentioned the REST API, the workflow ID there in VRealize Operations Manager, and it just fired the workflow directly. There's no in between handling. It's much cleaner. And since REST API for VROPS is pretty much well documented, you can utilize anything and do many things. That's one another part probably. But you can see that based on load balancer load HTTP requests and CPU and memory, you can do auto scaling end to end without zero touch. I say it zero touch because we didn't do anything in VRealize automation. We had that item. The items were automatically being added and removed. So I have now web 0201 and 3 was also added and then removed using VRealize Operations Manager and VRO and the webhook shims. So I would prefer webhook shims over SNMP any day, and then VRealize Operations Manager because you have so many options. So this is how you need to set it up, and this is how it exactly works. These workflows I have exported it as a package So this com.vmware.autoscale.package, I will upload it into my blog. So I will write a detailed blog here in my website, vtechguru.com. There I will provide the package link and the other information that you would require for this. So I am going to write a detailed blog as well. Go ahead and read the blog, follow the blog, and it should be good. Here is operations manager with VRE, with NSX and VRO. It's amazing the way autoscaling works is scale out, scale in, and I can do pretty much anything that you want. I hope this covers the entire topic. If there is any confusion that you have, you can always reach out to me or contact me on my blog and give me feedbacks. Thank you for watching this.